Good morning to all. Today we are going to discuss Unit 1 4 Data Quality and Standard. The topic is temporal accuracy. The temporal accuracy. The course outcome of this topic is interrupt the concept of data quality and standard. The program outcome is 1, 3 and then 5. The program specific outcome is 1. The course outcome is interrupt the concept of data quality and standards. So the scale, resolution and accuracy in GIS, because GIS data is stored in a very different way than paper map data. The relationship between map scale, data accuracy, resolution and density are different between GIS and paper maps. A map in a GIS can be shrunk or enlarged at will on the screen or on paper. You can zoom in until the screen display a square meter or less, or zoom out until the screen display the entire earth. This means that geographic data in a GIS does not really have a map scale. So NHD at two spatial scale. So 1 is to 1 lakh scale, then 1 is to 24 scale. So the stream and map scale. So see 1 is to 1 lakh scale and 1 is to 24,000 scale. So 20 times number of lines, 3 times total length of lines. So the sand macro basin flow lines total length is 1890 kilometer. Like 1 is to 1 lakh scale is 557 lines. Whereas sand macro basin flow lines 1 is to 24,000 scale is only 11,338 lines. So see the total length is 5,559 kilometer. The length of this San Macros river is 1 is to 1 lakh scale, 39 records. Total length is 130.0 kilometer. Whereas 1 is to 24,000 scale is 112 records. Total length is 138.1 kilometer. The 6% longer and 2.9 times number of lines for 1 is to 24,000 scale. So the accuracy and generalization. See the Austin city clay 1 is to 500. Here is 1 is to 12,000. So Austin silt clay. So houses black clay. So Austin black clays. So the different soil type boundaries are generalized when mapping an area, but are actually vague and graduated. Difference in scale allows fine resolution, but only if the original data was collected at a fine resolution. So this is the actual soil integration. This is the generalization on map. So accuracy is the degree to which information on a map or in a digital database matches true or accepted values. Precision refers to the level of measurement and externance of description in a GIS database. So the relating scale and accuracy. United States Geological Survey Mapping Standard requirements for meeting horizontal accuracy as 90% of all measurable points must be within 1 bar 30th of an inch for map at a scale of 1 is to 20,000 or larger, and 1 by 50th of an inch for maps at scales smaller than 1 is to 20,000. So these are the feet based. Okay, how the feet are increased. So accuracy standard will be changes different upon the scale. So the national mapping program standard, they are mentioned the USGS like a NMP standard document, like a digital elevation model standard, digital line graph standard, digital orthophoto standard, digital raster graphic standard, metadata standard, miscellaneous instructions, national hydrographic dataset standards. So the national mapping program standard available document like a version data available formats. So these are the draft standard for national hydrographic dataset, standard for national hydrographic dataset, I resolutions. So the stream or river, a body of flowing water. Horizontal data are confidentially positioned within 0.02 at map scale of the truth ground position. The vertical data are confidently positioned within one of contour interval of the truth ground position. So like a feet into meter, the formula are calculated. The assessment of the session is explain the procedure for identification of temporal accuracy. These are the reference books. Thank you.